Firestone Bay and Devil's Point are located in the Stonehouse area of Plymouth, in the southwest of England. This historic area is adjacent to Royal William Yard, a 19th century naval victualling yard, and commands beautiful views over the Plymouth Sound. It is, however, in desperate need of regeneration, with disused and derelict buildings currently occupying this prime location. Plymouth City Council have been clear in its ambition for Plymouth to become one of the most vibrant waterfront cities in Europe, where an outstanding quality of life is enjoyed by everyone. Volitare have put forward an innovative and visually stunning redevelopment plan for the area, replacing dilapidated, unused structures and areas with modern luxury housing and an expansive community hub. The project includes a restaurant, grocery store and conference space. At Volitare Engineering Ltd, we strive for the best and highest performance results. This video will explore the Firestone Bay development, detailing the key features and design elements of the project, as well as a company overview. Volitare believe that Firestone Bay and Devil's Point is an area of Plymouth that is underutilised and would greatly benefit from extensive redevelopment. The Firestone Bay development project was designed with the needs for renewable energy, aesthetically pleasing designs, and the sensitive treatment of the surrounding environment in consideration. With rising sea levels caused by climate change, the concept of floating homes is being explored for accommodation in locations close to or below sea levels, as well as in flood risk areas. Current floating developments are exclusively built within sheltered locations. However, this development has created an innovative solution for providing floating accommodation in a more exposed coastal setting, which is likely to be implemented more in the future. The Firestone Bay development project deliverables are split into 4 main sections: the breakwater, the floating village, renewable power generation, and the headland redevelopment. The design of the project has followed the relevant design standards and codes of practice to ensure the highest level of safety and efficiency. Extra care has been taken during design to guarantee that deliverables comply with BREEAM guidelines for sustainability throughout their life cycles.
Protecting the floating village community is a combination of a floating breakwater and a rubble mound breakwater. The floating breakwater has been designed by using existing wave spectra in Plymouth Sound and calculating the transmission coefficient of waves with varying breakwater dimensions. Also incorporated is a sea wall intended to prevent overtopping to improve the safety of the village. The breakwater has been designed to be guided by steel piles embedded into the seabed, which allow for the safe vertical movement of the breakwater with the tide, giving residents of the village an unparalleled view across the sound. The views are not limited to just the residents of the village. The breakwater will be open access during daytimes to visitors.
The walkway around the village is of a similar design to the breakwater, with floating sections connected together and guided by piles. The walkway is connected to the mainland through land connections designed to accommodate for disabled access. These are located at either end of the walkways and one on breakwater. The walkways provide access to 28 luxury floating homes. The 2-storey 140 square metre houses come complete with a rooftop garden and solar panels, 3 large bedrooms, 2 bathrooms, a spacious kitchen and a living area with incredible views. A further benefit of these houses is the inclusion of personal mooring spaces directly adjacent to each house. These spaces are large enough to accommodate vessels up to 12 metres in length. The houses have been designed to maximise the comfort of residents, with the flotation system being designed and validated with stability and motion response software. Further to this, each house is guided by 4 piles.
In order to minimise the carbon footprint of the development, the project will feature renewable energy generation, which will supply electricity to the community hub and floating houses, as well as some of the surrounding area of Plymouth. A tidal lagoon covering 21,000 square metres will be constructed, which will make use of the UK's extensive tidal range. A small-scale lagoon such as this will be the first of its kind in the world and will provide predictable and reliable power. 2 bidirectional Voith turbines will be used, which are specifically designed for low head applications. The sluice gates will control the flow through the turbines, opening 2 hours after a tidal extreme to generate power on both the ebb and flood tides. The turbines will be installed using a shaft which runs up the wall. This will also make access for maintenance very easy. 2 turbines will be used to share the load and to increase the flexibility to carry on power production if maintenance is required. The lagoon will produce approximately 287 megawatt hours per year. Wind turbines and a floating solar array have also been incorporated into the lagoon design. The southwest has the highest levels of solar radiation in the UK, as well as some of the best potential for wind energy generation in Europe. 40 small-scale horizontal axis wind turbines will be installed along the top of the lagoon wall. Similarly, over 3,000 floating solar panels will be moored inside the lagoon. This will utilise the vast sheltered area the lagoon encloses that would otherwise go unused. These solar panels will also be made more efficient due to the cooling effect of the water. These two renewable systems will complement each other throughout the year, with wind turbines producing more power in the winter and the solar peaking in summer. Annually, the solar panels are predicted to produce 238 megawatt hours per year, and the wind will produce 475 megawatt hours. This will be connected to the grid via a power control unit located in a repurposed building on the western edge of the site. This building will also contain the district heating system for the village and community hub.
The headland development is the heart of the Firestone Bay project. The community hub building is split into two sections, with the west wing dedicated to a restaurant, bar and event space. The ground floor restaurant provides space for around 100 covers, with panoramic glass windows providing outstanding view over the bay and Plymouth Sound. The kitchen and storage areas are designed to easily and efficiently cater for the guests. Above this is the event space and bar, which can be hired out for events and functions. The space includes a large balcony with stunning views of the seafront. When not in use, the space will be available for the restaurant. The first floor of the east wing is dedicated to a conference centre consisting of 4 rooms. Beneath this is a high-quality convenience store and post room, providing the community with easy access to day-to-day necessities. The steel frame structure, reinforced retaining wall and concrete pad foundations install stability against high winds. The building is built into the headland, reducing its profile and visual aspect on the surrounding area. The wooden balcony, external timber columns and stone cladding help blend the pub into its environment. To cope with the increased traffic to the area of the development is expected to generate, the existing car park has been resurfaced and overflow spaces have been created in a previous unused drained reservoir. The existing Firestone Bay beach requires extensive replenishment to revitalise the surrounding area, making it more aesthetically pleasing to the residents and the surrounding community. This is done by constructing a submerged sill 15 metres offshore and building up sand between this and the shore, removing the existing tidal pool and constructing new walkways and viewing platforms around the area.
Volitare Engineering Ltd currently consists of a multidisciplinary design team made up of 9 engineers specialising in civil and coastal, mechanical, marine and composites engineering. The team is led by project manager Rory McNevin. Matthew Vosper is the principal marine engineer and secretary. Kieran Kenworthy, the principal civil engineer. Samuel Evans, principal mechanical engineer. Harry Ross, principal coastal engineer. William Jennings, principal renewables engineer. Daniel Preen, principal structural engineer. Jonathan Parry, risk, finance and procurement manager. And Bartholomew Woolbank, sustainability and environmental manager. This team allows Volitare to achieve innovative design solutions at the highest levels of quality.
A SWOT analysis was carried out, highlighting the constraints of the Firestone Bay development, as well as any potential opportunities. The unique and innovative nature of the development could attract a wider interest which would stimulate Plymouth's local economy. This project could also lead to Plymouth's transition to becoming one of Europe's most vibrant cities. Volitare, being a young company, and the associated inexperience could cause difficulties in securing funding for the project. This may pose an issue for the initial cash flow into the company. The development will entice an affluent clientele due to the premium residences. This could cause complaints from the local populace through the planning stages, as the housing would be considered unaffordable to most. Environmental impacts of the project could also pose as an issue for the completion of the Firestone Bay development. Successful completion of the development could lead to Volitare gaining its positive reputation in this field, becoming leading experts in the area of coastal floating developments and small-scale renewable energy development.
Volitare expect the Firestone Bay development to be completed within 5 years. Project feasibility will be completed within the first 4 months of project commencement. which will follow on to a more detailed project planning phase lasting 3 months. To reduce the overall time of project completion, planning application and environmental impact assessments will be started at the same time as the detailed planning phase, allowing 6 months for application to be completed and submitted to relevant regulatory bodies. Correspondence of planning application decisions is anticipated to be received within 3 months of the application submissions. The tendering process of the Firestone Bay development will then begin, lasting 3 months. The detailed design phase of the project will commence alongside the tendering process and last 1 year. The remaining 3 years of the project has been allocated to construction and handover. The construction of the Firestone Bay development has been split into 3 main areas: the floating village development, including breakwater, the headland development, and the power generation development. All of the construction phases are able to run simultaneously due to none of the different areas infringing on one another. For example, the majority of the floating village development will be prefabricated off-site and floated in on barges for installation.
Volitare have estimated the total project cost of £59.7 million. This has been determined by estimating the plant, labour and material costs for each key design element. The headland development is estimated to cost £13.3 million, the floating village £40.4 million, and the renewable energies £5.5 million. All costs include overheads, contingencies and contractor profit. Project funding is expected to be achieved through the pre-sale of the floating housing, with payments made over the duration of the construction phase and final payments being received upon handover. This is estimated to raise approximately £45.6 million. The remaining £14.1 million can then be raised through the sale of the headland development or through a business loan. Further funding may be accessed in the form of grants. With the sale of the headland development, an immediate 5.3% return on investment is expected upon project handover, with a 50-year return on investment of 9.6%. Alternatively, through headland rental, a break-even period of 31 years is expected, with a 50-year return on investment of 16.6%.
The QR codes in this sitemap provide a link to 360-degree panorama renders of specific areas of the Firestone Bay development project. Volitare Engineering Ltd thanks you for watching.